So what do you say? Should we get started? Why not? My name's Howard Deiner. I come from the greater New York metropolitan area in the States. Okay, I live in northern New Jersey, but that's not germane here. I am going to be talking today about continuous delivery. We're going to have a lot of stuff on the backgrounds, the whys, the whats, talk about some of the hows. I do want to be able to talk and take your questions, all of them, even if it's WTF, what's that picture about? You know, stop me. Okay, otherwise I'll just keep on talking. You don't want that. So this is the talk of the day. Let's start with the problems, right? The first problem, how many people in here do like Scrum, something related to Scrum? Okay, so you got those little channels and it says backlog and it says in progress and it says done and it says complete, right? Stop talking about those things. Those things are meaningless. Okay, nothing is really done until it's shipped. Okay, done, as we'll talk about later, occurs in this fantasy land, you know, some controlled echo environment. Okay, we as companies need to start thinking about getting things shipped to show value, right? In this simplest case, right, a person orders something on the web, right? They get an email that says, we've got your order. They get an email that says, we're shipping your order. Okay, it's all complete, it's done. That's a lot different than this person taking the package and actually seeing if the stuff inside the package is what she really wants. Right? So we've got to stop talking about Scrum as if it's some mecca that gets stuff done. It gets them done. We get into the done column. We push teams. We get them to plan. We bring down the cadence, right? Make it a quicker cycle. We let at least some people inside the business see what's going on. That's all good. But what's not good is that the business doesn't get anything out of it. It's all sitting there waiting to be collected, right? So my conjecture is that release is the new rate limiting step, right? And those of you who remember your chemistry, the kinetics, talk about the fact that when you have a reaction occurring, it's the slowest step within the reaction that determines the reaction's length, right? In classical Agile and Scrum, that rate limiting step is called release, right? And we want to get better with things. I mean, if you ask the average person who's a product owner, how's Scrum treating you, right? Their actions will be like, hey, this is actually pretty good. It used to be like 9 months before I could get something done, right? Now it's only 3 months to get something done. And then if you keep on talking to them, they'll say, I got this really tiny thing to do. How come it's taking 3 months to get this thing shipped? Okay, it's because of the rate limiting step.
Most reactions take place in a series of steps called the mechanism of the reaction. The reaction can only take place as fast as the slowest step will allow. This slowest step in the mechanism is called the rate determining step of the reaction. This demonstration will illustrate this concept. On the ring stand are 4 funnels, each of the same diameter, and each funnel represents one step in the mechanism of a reaction.
This one's marked shipping,
Since each funnel has
releasing.
the same diameter, water will flow through the funnels at equal rates, and therefore there is no rate determining step.
A nice laminar flow.
I will now place a funnel with a smaller diameter on the ring stand. The smaller funnel will be the rate determining step of the reaction, and water can only pass through the series of funnels as fast as the small funnel will allow. Please take note of the time difference it takes to pour 1 liter of water through each series of funnels.
These are the people in operations that we're now bringing into place. We're actually releasing our software. Pay attention. Oh, this is also the part that takes the longest. All right, I'm bored. That was 3 months. I'm done. Okay. Why can't we have 3-day projects? It's a great question, right? The problem that we have has been around for a while, okay? And if you think about it, you started hearing the term DevOps probably around 5 years ago, right? And about 5 years ago, people said, oh, we got to deal with this problem where stuff is like done and complete, but it's not released. So we'll call a bunch of people into our scrums or whatnot, and they'll get to see what's going on. Maybe they'll even talk a little bit with some people in there, right? And they said, that's the way that you're going to do it. Actually, doing it that way doesn't accomplish very much, right? At the end of the cycle, we still many times like heave the code over a wall, or the ones that I really hate. Anybody in here do safe? Good. The ones that I really hate are the ones where we plan for like stabilization iterations. We're going to stabilize our code. What's all that about? Right? So, in my humble opinion, DevOps, or at least what we were doing that we call DevOps, has been a blatant failure for the last 60 months or so. Right? It's the same kind of a problem. We got 255 terabyte service. Okay, this is stuff that I think it was done up in Sweden. I forget now. I should have put it down there where it is, which is great, right? We could download a 1 gig movie in 31 microseconds. Then we got this tangled, twisted NID sitting outside our house with all these old wires in it. And eventually, we're supposed to ship stuff. That's where it actually gets delivered. Right? It doesn't work. It can't work. Right? We got to stop talking about reaching higher levels of agility and actually do something about it. Because you're not going to talk your way out of this one. You're going to need continuous delivery.
And your ass ain't talking your way out of this shit.
See, now it makes more sense. Okay, problems. Some rationale. So, long line, right? A single line, right? If we had a single line of code that need to be fixed or put in or whatever, right? And you wanted to do it quickly, you wanted quality in it, and you wanted to do it so that it was repeatable and reliable. How long would it take you to do that? Ask yourself, and be real honest about it, right? I still have organizations that I see pardon me, that call themselves Agile that'll say, well, changes to production, there's a lot of steps to go through, a lot of gates. It's like a year. But don't worry, we're pretty good at it because it used to take us longer. All right? The classic Scrum goal is every 90 days. You start tweezing that apart, and you start seeing that they're taking 2 weeks at the end to ship stuff or more. All right? How about a week? Most places that do things in a week aren't at the quality, repeatability, and reliability aspect. I was doing I'll name them. I was doing something in Bloomberg. Is that known out here, Bloomberg? Yeah. Okay, this wasn't the terminal stuff, but stuff that they were doing for like government and legal. They do a lot of publication stuff. And working with these fellas, they would love to ship. They would, have some code changes and ship it. And they'd put it in one night and then spend the next 3 days debugging it, okay, and trying to placate users that were horrified at what they just did. All right? They weren't ready for a week. How about tens of minutes? Could you do that? Actually, that's about the amount of time that it takes when you have a standard release kind of process and things start going wrong. And you find some hero, 1 o'clock in the morning on a Saturday night that's, making changes and putting the stuff into place. Again, it's not quality, it's not reliable, it's not repeatable. We just don't know how to do this stuff in most organizations. But here's an organization that does, right? 4 years ago, Amazon was measured. And what they found is that they could release stuff every 11.6 seconds. 11.6 seconds, which really eclipses what my favorite one was Facebook. Right? Facebook would release every 90 minutes, including the amount of time that it took to transmit that, 1.5, 2 gigabytes of compiled PHP and send it off to the, the content servers around the world. That was a 90-minute cycle with a backout time in it. Right? But this blows that completely out of the water. Right? Every 12 seconds. So you might ask yourself, isn't 12 seconds kind of crazy? Right? And in many cases, it is. In many cases, we can't process the results ourselves 5 times a minute. Right? But if you want to make what really counts in your business work, which is making good products happen, you'll apply the same sort of techniques that we do to make good software happen. Right? We're going to employ a lean startup thinking mentality to be able to iterate over our product. And there, the idea is that we have a little experiment. Okay? We have a little experiment that might say, given the demographic of this person looking at my web page and looking at some of their prior history in purchasing, I think that we could actually surcharge them 1%. Okay, because they're more likely to purchase this thing. And for the other people that are coming here and have this demographic, we're going to discount it to try to draw them in. These are little experiments that you may not even see, but if you're keen on Amazon, you ought to check sometimes. Have 2 people that, one person's never shopped at Amazon or something, another person that buys everything there. Check the same items. And many times you'll see a discrepancy. A/B. It's A/B testing. Right? And if you look at their stock price, they're prospering because of things like that. They're a very innovative company. And that's why they have to release tiny bits of stuff 5 times a minute, right? So that they can build better products. So we need to learn about this iterative development. This is not a session on lean startup, right? But as an organization, we have to do that. Okay, we have to quickly learn what works and what doesn't. It kind of, if you squint your eyes a little bit, the lean startup cycle of you get an idea, you build some code, you measure results out of that change, then you look at it and refactor into another problem where you either pivot, perish, or persevere. Right? It's sort of, to me, a little bit like red-green refactor in a TDD cycle. Try not to say too more about that. I know. If I ask everybody in the room why they don't do it, they say, well, we can't. We have a legacy code base. Here's a company that had a legacy code base. You may have heard of them. They're called Uniq Packard. So back in 2008, they went on a journey to see if they couldn't fix their problem. Right? Their problem was that they had code that was sometimes a quarter of a century old, all the firmware for their devices, okay, that was highly technical, highly difficult to deal with, right? And they wanted to reduce the amount of time that it took them to come up with releases, right? Because sometimes it would take them 2 years to come out with new software. And they said, this isn't going to work. Okay, so these 3 guys, they wrote a book about it. Here's the book, right? Now, truth be told, it's not just about DevOps. It's not just about tools. It's about a corporate mentality. But the tools and the continuous deployment aspect are a big reason that that stuff worked, right? So their results were that their development costs decreased by 40%. That's interesting. The number of programs increased by 140%. Also kind of interesting. Same kind of people, yet they could handle 1.5 times as much. This is another interesting number. Their costs for development went down by 80%, right? But the most interesting number to me is the last one, is that the resources that were working on firmware, Many times this 25-year-old legacy firmware that's all squirrely and hard to deal with, their innovation, okay, the stuff that they could do to bring the company forward increased from 5% to 40%. In my mind, that's a staggering thing, right? Because the innovation cycles went up 80%, 800%. You know, imagine what you could do if you had more people in your company, not just nursing the old stuff along, but actually building new things to drive the company forward, right? So additionally, they shorten their cycle times down. Again, drives innovation. So they could come up with an idea and pull that crank for innovation much more rapidly, right? The reality is, and I had this argument, was it over lunch? No, it was before lunch. Efficiency versus effectiveness. Who in the room is worried about efficiency when they're doing development? Who wouldn't be, right? Right? I claim to you that efficiency is like second order. It's not as important as effectiveness as an organization, okay, which is sort of like the efficiency of the organization as a whole versus the efficiency of a silo, right? To get there, the organization has to figure out what its bottlenecks are. They have to figure out how they reduce that kind of constraint. They have to stop blaming one another and become a learning organization, right? And it also means, unhappily, that the people that are working in development and the people that are working on the product and sales side have to learn to work together, have to trust each other. And they have to earn that trust. It's not something you can mandate and put on a sheet of paper. They have to earn it by credibility, by demonstrating credibility. Right? And that's what HP was all about. However, back to the continuous integration portions, that really wasn't as big of a factor as quality was throughout the system. Okay, we're going to focus on that in just a couple minutes, the quality aspects of continuous deployment. Right? You know, again, if you can't consume the stuff that's coming out of your system, if you're going too fast and can't really look at the results but just keep on pounding stuff out there, you're setting yourself up for a disaster. Right? So the example I want to give is that if I want to look to see how fast a car is going, I can look at the rotational speed of the tires. It's usually a pretty good indication of how fast the car is going. But if I jack up the wheels, or in this case, put them on a dynamometer, right, I could spin my wheels very quickly, but I'm not going anywhere. All right, so we can't just do this stuff, you know, on our own little cycles. At HP, they had lots of process improvement, lean thinking, waste reduction, work in process limits, there's constraints, blah, 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 blah. But test automation was really a big part of it. The willingness to move towards craftsmanship, technical excellence, right? Agile Manifesto stuff, right? Ultimately, we need those cycles to make the business work. Nobody stopped me yet. All right, so I'm going to tell you a story. And the story, half of it has to do with my wife. So listen up. I think that there's a relationship between Amazon Prime and deployment of code. Okay, what I mean by deployment is the stuff that, you know, after we're done with all of our iterations and it's sitting out there on a CI server, and, you know, what do we do with it then, right? Back in the old days, when you wanted to order something, let's say it was office supplies, you take a look at the site that was selling your office supplies. You'd search around and see which site is giving you the better price. You'd compute all of the batching issues. How big of an order do I have to make? Oh, if I order 10 times as much, the shipping is only twice as much. That's not a bad deal. Oh, but if I have that amount of inventory, then how much of it's going to sit on the shelves and rot? Okay, so there was all this batching stuff that went on. I used to get involved in the same sort of things. Okay, if I bought toner for my printer or whatnot. Of course, my wife still likes to buy stuff. It's not on Amazon Prime, but they I don't know if they have it here, but they sell stuff, and it comes in these huge boxes. And rather than go to the store and pick up toilet paper, I'm sitting there with a box about the size of this table full of toilet paper, but it was a little bit cheaper. So anyhow, she still does something like that. But that's not the point. The point is Amazon Prime occurred, and overnight everything changed. We have Amazon Prime out here, right? Yes. Okay. Details that you didn't know about Amazon Prime. Started in 2005, and it cost $79 a year. 79 was a prime number, right? In March of last year, they raised the price to $99. These are pounds. I don't know how they did it here, which is about what $79 is with inflation from 2005. Right? They got lots of great stuff on Amazon Prime. Okay, it's kind of replacing my cable, thank God. Free streaming. Okay, and then also the ability to purchase stuff along the way. Free second-day shipping. You get next-day shipping deeply discounted. So the curious part is some people have done some analysis on what Amazon Prime costs Amazon. And Amazon loses about $11 per customer when they sign them up. Okay, which really reminds me of my .com days, where the joke used to be, well, we'll lose money on each person, but we'll make it up on the volume. Yeah. Okay.
So lose in the sense that they earn less than they could have without, or like?
That's right. Every person that they sign up, they actually lose $11. Because they would have otherwise got more shipping done, more shipping costs associated with them. But stay tuned.
Okay.
Stay tuned. Now, nobody asked me about the picture yet. Why is this picture up here? Why is that picture up there? Volume. Good. Okay. There's something behind each of them, So Amazon is a company that deeply believes it's deeply a learning organization. And they have a lot of holistic thinking that goes on. And they are worried about less friction per transaction. Okay? The rate limiting step, if you will. They want to relieve that thing. Okay? Now I'll talk about my wife and why Amazon really works. I did a study on it, but it was an N of 1. Right? So my wife, that's the next slide. Right? The reason that it works is because of batching. Right? I trust Amazon. Their prices are always competitive. If I want something, I go to Amazon, I press the button. I don't have to worry anything. 2 days later, boom, it's in my door. Rather than have all of that thought process that I used to do, now I just go to Amazon, purchase it, and there it is. Okay? They win on those things, but it takes time. Right? Our experiences are quick, easy, safe. Why wouldn't I do that? Now back to my wife and her feet. Okay, my wife has foot issues. Isn't it interesting? Foot is like singular, but feet, which is like what most people are born with, is plural. And then a yard, it should be 1 foot, 1 foot, but we don't talk that way. Anyhow, my wife has foot issues, although she's got 2 of them. And she's really hard to get shoes for, which used to mean that we would go from store to store while she looked at shoes, determined if they met her specifications, if she could wear them, what was the fit like, what did they look like, all these horrible things. Spent many a bad weekend with that stuff, all right? And she would never go. I would always just like, hey, I need this and that. 2 shirts, pair of slacks, shoes, belt, everything, just order it, boom. In fact, there's nothing that I'm wearing here that I did not order online, including the underwear, okay? But my wife was really different. She really didn't like doing that stuff, right? When I showed her Amazon Prime, everything changed. It changed because now she just goes to Amazon and orders the shoes that she thinks might work, right? Things that she kind of likes, things that kind of have the right stuff, things that are in her size. And if she doesn't like it, when she sees it, she sends it back. It's very quick, it's very easy, it's very efficient. Okay? What she's doing is experimenting on value for her. Okay? And at very little cost to her. So everybody has product owners that look like this, right? But this is right in one way, is that most corporations, and everybody's happy, they go, no shouting and pumping of arms into the air. Anyhow, there's an analogy between my wife and product owners, right? Product owners' standpoint, they see a feature that they'd like, okay? Hopefully something kind of small, like shoes, right? They see that feature, they feel comfortable with the team, they know they're going to get it done. Very little waste involved because they can put it in place, get results or not, take it out if they don't like it, right? If we could do that, we could get rid of one of the things that drives me insane from a lean standpoint, from an efficiency standpoint, by the way, which are meetings. Anybody here like meetings? Everybody have one of those great meetings where everything clicks, everybody gets along and gets stuff accomplished? I didn't think so. Right. I'm not alone in this. We don't need meetings. All right. From a lean perspective, a meeting, a planning meeting like for a release, is simply a cost without a customer benefit. Kill it. Figure out a way to not do that. All right? There is going to be a certain amount of waste that's going to occur with every kind of release. That's pretty much unavoidable. Right? But we shouldn't be putting up with it, right? We don't want to have these meetings where everybody is sitting around and saying, well, gee, what if that happens? Or what's your answer to this? Well, there's an action item I have to take place, and we'll try to get together next week and talk about that stuff. What if we were able to reduce the cost of having a problem if we had one? Or, even better, not have the problems to begin with, right? Rather than getting really good at fixing stuff, maybe we should make things that don't need fixing, right? So I want to get with less meetings and less waste, but that's just me. Amazon's the same kind of way. By the way, I put this picture, and we bought a dog last December, and it's a Sharpei, although it's a little bit darker in color than that one. They're very cute. Amazon eats its own dog food. That's the reason that the picture's there. All right. When they release every 12 seconds, it actually isn't their maximum rate. They've done almost 1,100 releases in an hour, going to kind of a big place, right, up to 30,000 hosts that were affected by those kind of things. All right. They are very concerned about things like outages, about deteriorating a customer experience. They never want to have that. They plan around that kind of stuff, right? They take an idea, they deploy it rapidly, they look what happens, and they pivot, or they persist, or they perish the ideas. They do it in a very quick way, right? Enough with Amazon Prime. How do we get closer to it? Well, everybody here probably does some form of continuous integration right now, right? Yeah, pretty much. I mean, that's, 5 years ago that was like, wow, continuous integration. Now it's pretty much du jour. You got to do that stuff every day. The goal for us shouldn't be continuous integration, right? We need it. It's necessary, but it's not sufficient, right? Because we have to get to the point where everything that we produce has the quality that we can count on, right? And that's going to involve a lot of automation in things like testing, right? But not just testing, because you can't test quality into any kind of a product, right? Sometimes there are other things about it that actually matter. I believe that it all starts with the code, right? I believe that architecture matters. Everybody in here, what kind of source control systems we use in here? Subversion, Git, CVS? Whoa, good. Okay.
Mercurial.
What was that?
Mercurial.
Oh, Mercurial, okay. I don't know that much about them.
Similar to Git.
Similar to Git. Fine. branching is something that everybody in here does, right? Good for you. Good for you, and I'll say why in a second if don't destroy my lines here. Who in here branches like every iteration? New iteration, new team, we put up a branch and it's there for about 2 weeks. Who in here uses feature branching? Shame on you. Why do we do feature branching? Why do you do it? Risk mitigation. I can build out this stuff on this branch, and eventually they'll ship it, or they'll decide, oh, that was wasted work. Right? You do feature branching also?
Yeah, for prototyping.
For prototype, how long do they last?
A month or two. I've only actually just started using it, to be honest.
Well, stop. Using them for a month or two, that's too big. Oh, I forgot. That's another good one here. Yeah. The reality is that branches in general are a waste. If we could do stuff directly on trunk all the time, perfect. The reason they're a waste is that every time we have to do a conflict merge, like you got some big branch sitting out there for a feature that may or may not get used, right? God forbid, 3 months, 4 months down the road, product owner says, oh yeah, ship that thing, right? The distance between, the rest of the code and your code is like getting bigger every day. And after, a month, 3 months, the amount of work that you have to do that's error prone for things like conflict merging become a real issue. It actually doesn't decrease the risk in a real sense. Okay? It's an architectural thing, right? We would be much better off getting to some loosely coupled architectures, okay, with interfaces that are resilient, right? So Martin Fowler, Dan Boggart talk about feature branching as a poor man's modular architecture, right? And there should be using things like feature toggles, branch by abstraction, even microservice bus architecture, okay, which I think we're getting a lot of at this conference. A lot of people talking about that. You should really look it up, right? If you're not doing it or thinking about it, the reason that it's so good is that it's a way to completely decouple the parts of your application that have clients and servers. Yeah?
But it's not possible to completely decouple everything. We have modular architecture, but we have a core after all. We have some integration points, and sometimes you need to change the core. So what do you do with that?
So we're talking here about web services versus somebody looking for service, right? I mean, that's one of those hidden dependencies that's out there that makes people want to go to large releases, right? So we have to break that dependency. And architecturally, I think I talked about it in this one, maybe if not, it'll be tomorrow. But architecturally, we've got to do things like excel at things like dependency inversions, probably by dependency injection. The microservice bus architecture really gives us a way to get in there. Because if we make it so that the guys requesting, the clients, will request for a service, but if that service is not the newest one that they really want, they can degrade to one that's being supported already, okay, with only a minimal amount of degradation. Then we can release stuff on the server side as much as we want. We can release stuff on the client side as much as we want. We don't have to have them in the same big old fat release. And that also will start speeding up stuff. That makes sense to everybody I'm talking about?
Yes,
But it's not possible.
no, it is possible. But for instance, I was talking something like if you have a feature A, B, C, like in the workflow.
Yeah.
But then sometimes you need to change that workflow and you need to have D before C.
Uh-huh.
And then you don't have that integration point in the core. So what do you do with that?
Well, and again, this is a problem that's solved, right? The workflows that you have are controlled by some kind of a service that says what the mealy machine is for this service, right? I'll have a new workflow that either is going to take all the old ones and upgrade them into the new one, or we just complete the old ones with the stuff that is already out there, right? And this is a perfect example of where microservice fits in, right? I can release new workflows all the time. It doesn't affect anything. I can release my clients at any point in time. They may not be able to get the workflow I'm working on right now because it hasn't been released, so they use the old one for a while.
Yeah, but that's why we use the branch.
Well, like I say, the branches are or have waste involved in them because of the conflicting that goes on. I'd much prefer to see you go out there, put the new workflow together. We're not ready for it on the client side. We'll stick it out there anyhow. Get it off your plate. Have it take a day, 2 days, whatever it takes. But waiting for all the dependent pieces to come together is a real danger and a very wasteful thing. We can talk. Right? Everything's got to get automated. If we're going to get better at stuff, the things that cause manual assertions, you'll hear me say that a bunch today, manual assertions have to get fixed. This is going to include testing things like deployments. Okay? It's going to include things like how do we provision our machines. Hopefully we're provisioning things like on virtual machines. That would be helpful. Right? We're going to be testing things like database migrations. We're going to be bringing up our systems, and before we turn them on, we might run a little smoke test. Who knows the definition of a smoke test? Let me describe that to me. Sanity test on the system. How long does a smoke test take? Could be for aircraft. I actually had somebody, she was a project manager, try to describe it, and she said, well, it's the average amount of time that it takes a project manager to go out and have a smoke while the system comes up. And which I thought was clever, but it's fast, right? It actually comes from electrical engineering. I had a guy that worked for me once. He used to work at Calcom plotters. Remember plotters? Right? And he described how they would build circuit boards and run a smoke test, which meant plugging them into the mains and seeing if any smoke came off the board, because then they knew they didn't have to test anymore. Right? And that's really where it comes from. Anyhow, smoke tests. We want to get humans to do things like verify stuff, not do the actual testing. We need those costs to stay tiny. Right? Is there going to be a cost to it? Yeah. But in the words of Warren Buffett, price is what you pay and value is what you get. Now, the costs are not going to be huge. Right? It might be huge at first, getting around to thinking in that way and getting some of the skills that you need. But eventually, once you can start delighting your product owners, right, it's money well spent. The corollary of this is that every time something goes wrong in a deployment right now, you've got time and money invested in fixing it, okay? Especially that time element, right? It stretches your cycle times out. So would you rather keep on doing the same thing that you're doing, which isn't really working, right? That's kind of like a definition of insanity. Or would you like to try something different? So there's going to be a cost, but we have to make sure that every build is a release candidate, okay? Because that's what empowers your teams. That's what empowers your product owners to say, that's great, ship it, and have that happen really quickly. So in terms of making things safe, we've got to build confidence. And the best I could come up with for confidence was Jesus Quintana. So see if you can remember this. Now, when you see Jesus and his partner here, think of them as your team. And when you see the dude and his partners, think of them as the competition. No quiet clapping. How do your competitors feel?
Fucking Quintana. That creep can roll, man.
Yeah, but he's a pervert, dude.
Yeah.
Remember, that's how your competition is talking about you after you get to the point, right? All right, we're almost done. This is the last part of this boring portion, right? Real rationale about doing this stuff for continuous delivery is about working your business as a whole, right? It's not about the CI stuff, right? But we're talking about a difference in culture at the business, one that understands iterative product development, one that understands organizational effectiveness. Anybody in here familiar with the Agile Fluency model Deiner Larson has? This is actually like the third and the fourth step of Agile Fluency, is the change that it takes in an organization to work together, okay, and to work at an optimal way. It's including all the technical practices, including all the stuff that you do with Scrum. But that's one of my favorites, is that Agile Fluency model. All right, enough with that. Let's talk about some practices now. All right, and the first thing, of course, that I'll tell you what to do or how to do is how to do it wrong. All right, because I know a lot more about that. The best way to get stuff done wrong is to put together a DevOps silo. Right, so many places say, oh yeah, continuous delivery is a pretty hot topic. We have to have DevOps. DevOps has specialized knowledge. They need specialized tools. Oh, well, let's set up a DevOps team, right? And then again, like we'll invite them to our scrums. We'll make sure we talk to them every now and again. No, it's yet another silo that you're going to have meetings with. Doesn't work that way. Furthermore, who are the people that know the best how the application is put together and needs to run? Peter, who are the people that are the best?
The one that write them.
Yeah, the people that wrote the code. They know how it works. Right? I mean, we need to involve them a little bit more. Right? So continuous delivery does have a bunch of tools associated with it. We'll talk about those in a second. Right? But I don't want to have people just standing around waiting for a handoff. Again, that's a cost without a customer benefit. It's something we want to get rid of. Right? And to get there, we're going to have to learn to break dependencies, not just get more efficient at handling them. Right? We're not about a bunch of tools. Right? The stuff that we're doing is a lot deeper than that. It's really more about reducing time. I can't say that enough. Right? If you remember back with the long line of people making a single code change, a single line of code, okay, if it takes you a long time to do that, right, a simple customer request, simple product owner request, it shouldn't take that long. There's no reason for it. And to do it safely, you can't take shortcuts like say, oh, we didn't change that code over there, so we don't have to test that. Right? Unhappily, software is so complex and has so many hidden side effects from things like if statements that are dangerous that eventually you have to test everything. All right, so I said do it wrong. Craftsmanship, right? It all starts with the code, right? We need a code base that's maintainable and that's malleable, one that doesn't crack every time we try to do something with it. That means that the code has got to be like loosely coupled, highly cohesive. These are things that should not be new topics. These were new topics 25 years ago, right? But it's amazing how many people forget or don't worry about that stuff, right? Probably the biggest topic on this stuff is not about how many abstractions we can put together in our code, but how readable our code is, right? Because computers don't really care how awful the code looks. I mean, they're executing bits and bytes, either in a virtual processor or within, real hardware. They don't really care how bad it looks. It's the next guy who's trying to read the code, even if that next guy is you, where it makes a difference. To understand the code is the way that you're going to be able to extend it without breaking stuff, right? So one of the big things, one of the big changes is making our code testable, right? How many people in here, and be honest, actually write code using test-driven development? Good. We'll make it 2. Because it's really hard to do. It's like, test-driven development is a lot like being on a diet, right? It's the good thing to do, but it's hard to stick to it, right? But the more we can do at least test-first development, the better off we're going to be. It's part of that craftsmanship stuff. If we can't test our stuff, then we're never going to know it works. The reason I asked this about who does their stuff by doing true TDD is that I'm a technical coach, and so many companies that I go to, it's like, all right, well, let's get those unit tests in place. And people start looking around like, unit tests? How are we going to do unit tests? And they think about, or even think, what are unit tests? Oh, they're small tests that you run. You give it this thing and you see what came out. I was like, well, first of all, it's got all these manual assertions. You're putting all this data together for it. And second of all, it's taking all the layers of software together. This is not a unit test, right? Then you look at the code, and you find out that this code is like untestable because it's got all kinds of hidden statics, that are private to the code, and they say, well, how are you going to test that? And if you're working in something like Java, you start pulling out Mockito and PowerMock and all kinds of crazy mocking frameworks to help through it. And you have the same kind of stuff. People in here are primarily .NET people. Yeah. Same kind of things. There's other different line of products. But we've got to get, back to craftsmanship. Right? We've got to start thinking about single responsibility, which is where most of that private stuff, starts violating. Simple methods. We've got to think about simple design. All right? Again, mentioned in the manifesto, simple design isn't simple. Sometimes it's really hard to figure it out. All right? Architecture, again, is important. Architecture, I'm not going to ask the question because the answer is on the first line. Architecture is defined as the design decisions that we make that are difficult or costly to refactor, right? Which it isn't just, the larger architectural issues, okay? A lot of those have to do with like non-functional requirements. These larger, how are these things going to execute? It's going to execute over there and get a message back, and should that be a message queue, or should we make asynchronous? It doesn't. Those are larger questions. We make architectural decisions all the time. Okay, making your code testable is usually an architectural decision that you make right around the time that you're writing code. Right? Talked a little bit about these things before. Okay, dependency and versions are going to help you. They're the thing that will make your code testable. Right? Feature toggling, microservice bus, break dependencies also, but they break them at a higher level. So if you're interested in how I can release faster, those are the sorts of architectural decisions that you should be starting to make. There's always going to be the problem if you have a large existing code base of how you go about doing this. All right, see me later. This is not so easy to answer. All right. What is important, what is easy to say, is that we need to be able to take pride in the code that we produce. Okay, if you're going to get a nice, tightly cohesive team, they all have to not snicker at one another and say, oh, it's Fred's code again. I'm not even touching that stuff. Right? And we should all be proud about the stuff that we work with as a team. That should be part of the stuff that we deal with. And the easiest way to do that is to think about the fact that the next guy that's looking at your code, always keep in mind, he may be a homicidal maniac and he knows where you live. So if you stay with that, you'll be fine. Various kind of testing kinds of things. I'm going to start off with how do we know that we built the code right? Because that's the domain of unit testing and TDD. Right? Anything that's not too simple to break must first have an automated failing test written before the code gets written. Okay, those are the words. Hard to do, right? If you're not going to do that, at least start thinking in terms of behavioral testing. Okay, stop, obsessing about what's my code coverage. All right, how many people in here watch their code coverage? You have a server that watches it. How many people do that because their boss is watching it? It's a management level thing. Right? Code coverage by itself is meaningless. Just means that, each of those lines executed once, some meaningless little tiny unit test. Right? But it doesn't mean that it can accomplish the work that it needs to accomplish. Right? So you actually have to start about doing these kind of tests thinking about functional things. Which is why with TDD, we start off with things like a story and then break our way down until we're finally doing the unit tests that need to happen, and then bubbling it back up into the story level features that can be tested quickly through dependency inversions. And that can be tested thoroughly on a fully integrated stack by flipping a couple of configurations and running it at night. Right? There's all those mocking frameworks. I almost wish that there weren't, because again, in recent memory, been working with a lot of teams that say, this is great, I got to learn how to use this mocking framework better, and they can spend days, I don't let them go for days, but hours, where they're trying to get it to work in the mocking framework, and they're facing tooling issues, but the real problem is not about the tool, it's about the stuff that has to get done. So they'd be even smarter at those kind of junctures to say, man, this thing is screwed up. Let's write an interface over here, and let's put a fake in, okay, because it's way too hard to get this mock working. All right, so don't get strung out on the tools. That's the wrong way to think about it. Pair, gang programming is an amazing thing. All right. I know that the same managers that are looking at your efficiencies in terms of how many lines of code are red and how many lines of code are green will not get it, right? But pair and gang programming works. It works because you're getting rid of you're getting the results right the first time, sort of, right? You're getting somebody who's doing stuff and somebody else who's thinking about it and saying, don't do that, here's why. Or you're going about that all wrong. It also gets rid of meetings, and you know how much I like meetings, right? We don't have to have design reviews, which probably nobody in here is doing very much of, right? Anybody do design reviews, code reviews? Ooh. Not a bad thing to do, I have to admit, but there's a much more efficient way of going about that, which is pairing. Okay, once you start doing that kind of stuff, you'll see that there's less need for those meetings. The other issue I have, of course, with especially code reviews is that most people don't really take the time to do efficient code reviews, right? They get sent something in the mail that says, we're going to have a code review next Thursday at 3, and here's what we're going to talk about. 5 minutes to 3, people start to peek at the code, or they don't, right? And at the code review, somebody puts up code, and people know they're supposed to say something, so they say things like, well, your curly braces are not right, or I don't like that name, or, other meaningless mechanical sorts of things, right? To really do a good review takes a lot of work. And you do that work, an inch at a time when you're doing pair and gang programming. So anybody in here do pair programming? It's good. I worked for Solution IQ back in Redmond. And this is kind of recent. I was working for Big Visible, and then they were acquired the first of the year. These guys in Solution IQ are like nuts about pairing. They want to pair on everything, and it's kind of cool, right? And it shows in the organization. You know, every place where there's a computer, there's 2 screens and 2 keyboards, and works nicely. All right. Did we build the code right? That's great, but did we build the right code? Now, there's a lot of controversy about what you call this practice. Okay, the practice of finding out stuff beforehand, specifying things. Some people like to call it acceptance test-driven development. Some people like to call it specification by example. But whatever you call it, it actually means starting with tests. Okay, and what I really like about it is tests that can be or should be surrogates for the things that we used to call requirements. Okay, and if you do it right, and doing it right means it's being written by the 3 amigos. Who's familiar with that term? Okay, I'm going to talk about it a lot tomorrow. Come to my cucumber session. We'll talk a lot about that stuff. 3 amigos are the people that you should be using to write your acceptance, your higher level integration test put together, right? They're the ones that are starting with something in a business sense and able to translate that into something that can be automatically, systematically, reliably checked in the automation tests. 3 amigos consist of a BA sort of a person. Ooh, I use that bad word, but a business sort of a person, right? They're the ones that know what they need. They need a developer sort of a person to decide, is this stuff doable? How am I going to write the framework around this test? What am I going to use? What I'm going to put in here? Okay, and some semblance of reality, right? And then there could be some negotiation back and forth. There's a lot of negotiation, or a lot of communication, I should say, between the business people and the developer, right? Because they don't understand what the terms are. They give them the terms, and they realize they're talking about something else. There should be a lot of that kind of talk going on. The 3rd amigo is a QA sort of a person. Again, I don't like using those kind of titles, but they're the person that's there to make sure that nothing was missed. All right, so if you develop your requirements up front using ATDD, it's kind of sweet. All right? I love this picture. This is actually a picture from someplace like in Las Vegas at some souvenir shop. It's not funny. Okay. We got a whole plethora of tests that are sitting out there, but the question comes up, is it enough? When is it enough? When will we know that our code is correct? The reality is that kind of never know. Okay, correctness is something that you can solve at a mathematical level. All right, people have actually gone back and you can go through and say, this code is correct. Don't know the name of the fellow. I could look it up. I graduated MIT in the mid-'60s and had a very efficient algorithm for division, floating point division, which was like a big field back then, like 1965. He published it in a master's thesis. And it was so good that chip manufacturers started to pick it up. Okay, and AMD in particular was still using this fellow's floating point division algorithm until, I don't know, sometime in like the 2000s, right? They had actually finally proved that it divided 2 numbers correctly by then. And they also found out there was a little minor error in it. Okay, so you can never really get to correctness. It's all about scientific method, hypothesis. Right, we put together a bunch of tests. All the tests pass. Our hypothesis is that the code worked because all the tests pass. Then we have a new thing. We write another requirement, another story, another feature file in Cucumber, or a new scenario, whatever. Our hypothesis is that this new thing is working and everything else is working, therefore the system is still working. But it's not any different than general relativity, right? We are still testing that every time we have a solar eclipse to see if Mercury is kind of out there and that if there's, magnification going on by the gravitational field in the sun. Still a hypothesis. Nobody has proven that one. So we're no different than that. You can measure coverage, right? It's particularly important when you're doing legacy code. I hate it, right? For the reasons I was talking about before. You need to functionally test this stuff. Now, if you're really into QA, I doubt that any QA people are in here today. Yeah. There is this thing called pairwise, what do they call it? Pairwise combinatorial testing, right? So actually, what do you call that? Edited a chapter in a book about this. It was started by some guys back in what was called Belcore, used to be known as AT&T Labs. And the idea is that if you have a whole number of variables that go into an application, that it's most likely going to be one of the variables with a problem, right? And if you can pairwise check each of the variables with something else, you can come up with the smallest number of tests that are possible to check every 1- and 2-fold item and verify correctness, verify functionality rather, right? So it's called all pairs testing. You can use it. You can kind of look it up. It's kind of outside of this, but I thought I'd mention it. All right, so we're building the right code. What then? Right? Now we start thinking about the deployment aspects. In particular, can I deploy my stuff correctly? First thing to realize is that the repository that we use that stores all of our source code, all of our scripts, everything that we want to do to deploy, build and deploy the application, we need to use that as kind of like a time machine. We shouldn't be afraid to go forward and put together some kind of a quote-unquote releasable candidate. Doesn't mean we have to use it, doesn't mean we have to push it out and deploy it, but every one of those should be working. The problem is that it's really hard to get to that stuff, right? We want to make sure that our repository is something that we can count on. Should anything else go wrong, we can always revert back to that version, right? Stuff inside there is going to talk about how the services get configured, the kinds of scripts that we might use to deploy, or to provision machines with, right? Everything's got to be automated. There's only one problem that most shops face, and that's with databases. Who in here uses relational databases? I'm sorry. I'm really sorry. Relational databases have been a problem since the beginning of time. Those darn databases. Darning. All right, I got to go back and fix these. So relational databases came around about 30 years ago, and they were a big deal back then, right? And of course, the word of the day was, all right, all you administrators, time to do a database, go out there and gather all the requirements from everybody, put together the schemas, put together the database, satisfy all the needs of the project, and then development can start working. The reason they had to do it at first was that it was very difficult to change the databases once they were in place. There was risk involved about things like upgrading the version of a database from one to another and what fields were now required and how they would do that. And there's also this prevailing thing about the job of the DBAs was to get the requirements right the first time. And it was kind of a failure if they didn't do that. Forgetting about the fact that you never can get the requirements, all of them up front, but anyhow. So DBAs started thinking about databases as something that you put together once. Maybe you did some monitoring on it. Maybe you checked to see if you need a couple more indexes. Okay, those people doing database stuff, right? That was like majority of people. What kind of tools do you use to upgrade your databases with? Who?
Entity framework.
Entity framework stuff. But the database itself.
Migrations.
The migrations, the automatic migrations under .NET stuff? Or you manually put them together?
The automatic, but we check them and we can modify it.
This is good. Okay. Ruby people will also like to answer like that. Right? We got our rake out, Who else does anything with databases? What do you use? SQL compare. So when the database comes up and it looks like this table went away and this table came up, then you know that, oh, I got to delete that table and this new table comes up. But it never captures things like modifications. Like in this case, modifying the name of that table. Not to single you out.
You can assign, you can
Manually. You said the right word. What do you use?
We've got a custom package that will go through and do
Compares.
compares.
That bad word, compares. You see, the compares are kind of like the conflict merge that we do in version control. Right? It's dangerous. It's nasty. It's hard. Okay. Because things have changed in the last 30 years. And nowadays, I like to start thinking about treating our databases like code. Our code at a particular standpoint needs a certain amount of back-end work to actually put stuff in a repository and save it for us. Subversion, good. That's a good place. But skip ahead. There are some tools that you should be looking at. Right? We got to start treating our databases like code. Right? We've got to actually be able to check in, like you're doing, all of the stuff in the schemas. We've got to be able to check in any kind of scripts that we might need to do those migrations, the ones that can't be handled manually, automatically. We should be able to use our repository again as a time machine. At any point in time, if I say, this version is not working, I need the one from 2 versions ago, we should be able to reliably go back and create everything from first principles. Well, yes, you can. Yes, you can. Yes, you can. Use this tool for years. Okay, it will change your life. Okay, so take a look at Liquibase. The guy who started it, Nathan Voxlin, has gone on to work in a commercial version of that thing for Datical. And there are other vendors that do this kind of stuff too. Right? But we have to be able to version control the databases and be able to make sure that we can maintain the linkage between the version of a database at any one point in time, the version of the code at any one point in time. I'm sorry? Yes, they're another one. Uh-oh. 20 minutes. All right, so continuous integration starts, and something goes wrong. All right, something goes wrong. One of the tests starts failing. What do? We pull the ending cord. Okay, I'm not going to ask who knows about what ending cords are. I'm going to tell you what they are. Ending cords were developed by Toyota in their Toyota production system when they started kicking the pants out of Detroit. And the difference was that back in good old Detroit, they have an assembly line with 100 cars or more on it, right? And if something didn't work, like they put the mirror in, but the screw holes didn't line up, so they'd kind of try to force it, and maybe the mirror's kind of canted a little bit, or whatever, okay? And they just keep on going. All right, you got it good enough, let's keep moving, let's keep rolling. By the time that somebody said, wait a minute, we can't sell cars with mirrors on them that are doing this, right? At which point you got 100 cars or more with defects on them, right? Even if they were good at fixing those defects, it wasn't the same as if they built the cars without defects. So what Toyota did was they put this big old line down the assembly line. And if anybody on the line saw something wrong, pull the cord, everybody stops. And they get to the root cause of what's going wrong. And in the case I'm just talking about, they say, well, the holes on the mirror don't match the holes on the car. What are we going to do about this? Now, probably they would go back and fix the holes on the car so they could screw the mirrors in. But it also could be that they just say, we're going back to the manufacturer and telling them to give us the right stuff. It's about effectiveness. Again, it's not that the line is running nice and quick. It's that they're producing quality cars. So we need to pull ending cords ourselves. Right? We need to be able to say there's a defect out there, Stop the line, let's go fix it. Everybody, all together now. Right? Another thing that goes on with this stuff happens with how quickly are all of your tests running. Right? Now, you guys that are doing TDD, both of you, probably check in your stuff like every time you have a unit test that's working. Pretty much. That's the gold standard. All right? We're constantly testing this stuff, and the unit tests that are out there are running lickety-split, tens of thousands of them in a second. We can do that. A lot of shops aren't quite at that level yet, right? But when I start seeing places that are going for like hours between check-ins, or if I start seeing people that are trying to do unit tests and it's been more than 5 or 10 minutes in that case, I'm going to say that things aren't right. You should probably go back and start checking in a little bit more rapidly, right? Again, it lets us know that problems occur quickly, and that's important. Yeah. Why not? So, first job that I had as a software architect was for a very big product that was big in the mechanical engineering space called Packard, and it did finite element analysis. And our whole company, PDA Engineering, was built off of this product. So it was kind of important. And we were kind of late with this version that I was responsible for. We were kind of late. So it wasn't a pleasant thing. The people that were doing like shipping and stuff, they didn't have anything to do. You know, salespeople were climbing down my neck. You know, and had a staff of like 100-something developers, and they wanted to know, what's the big deal? Well, as it happens, one day I was in the men's room, right? And you guys will know that there's like these unwritten rules, right? When you're standing in front of the device, you know, somebody's supposed to like skip one, right? You're not supposed to stand together, right? And I was out there one day, and who's standing next to me? Lou Delmonico. Who's Lou, you ask? Lou is the CEO. There's a second rule, okay, in men's rooms. No talking, right? Lou looks at me and says, so, how's everything going? To which I am very uncomfortable and say, great, Lou, just everything's fine. And kind of like hurry along, wash my hands, get out into the hall. Lou's on my tail, okay? And Lou says, wait, I got something to tell you. I got something to show you. I say, okay, sure. And then he says, somebody, throw me a marker. Somebody takes a permanent marker, like this kind of one, but it's black, throws it to Lou. Lou goes up to the wall and draws this. I say to Lou, Lou, you're drawing with permanent marker on the wall. And he says, yeah, I know. You know how late this product is? You know how much this is costing us? A gallon of paint will cover this stuff up, and it'll be $15. Here's Lou's story. Lou wanted to tell me why patching was so important. And he said, what if somebody was designing a car, mechanical engineer is designing a car, designing a disc brake for a car. He draws a circle. They make the cars eventually with those kind of disc brakes. 6 months later, people are dying on the highways because those disc brakes were too small and they're overheating. And they're smashing into other cars and causing deaths and whatnot. The costs of fixing that kind of stuff are astronomical. Could cause the company to go out of business. Said, now on the other hand, if they could figure out that there was a defect by the time that they were getting into like final assembly, the cost of fixing them would still be pretty large, but not quite as large. You haven't shipped out millions of cars. Said, if you could find that defect when they were building the very first car, prototype, in the engineering lab and about to run it around the parking lot, which is what they really do, right? It's still costly, but not as bad. He said, if we could find that there was a defect when the engineer was actually drawing the circle, a big message comes up and says, disc brake, too small, accidents may happen. Cost of fixing would be almost nothing, right? So it's very important that when we're doing, one of the rationales for doing all this testing is to get the time between the defect occurring and the defect fixed as close to the left side as possible, right? Because this is what it looks like when you're out in production with a defect. This is what it costs you when you're in like UAT or something like that. This is like, you know, the QA team on the integration server, and this is like in TDD. All right, back to the show. So, building and testing is much more than just a controlled environment. So this is Disneyland, right? That's a controlled ecosystem. Everything in Disneyland is great. They even come by when they have the horses. You almost never see horse droppings because there's a guy scooping it up right away. Everything is perfect in Disneyland, right? Unhappily, many of the times that we show and demo stuff to our product owners, it's in these controlled ecosystems that we call our integration server or something of its like, right? We've got to be able to move through environments easily, frictionlessly, with reliable results, okay? Because the testing has to occur in all of the environments, and eventually, and pretty quickly, it should get shipped, right? The sorts of environments, I'm not going to make this long. The normal sorts of stuff that we use are desktops, our continuous integration environments, QA servers, which tend to be just a little bit more stable. So QA types can do exploratory testing and all that other kind of stuff that they may do. Some kind of a pre-production area. Many times the pre-production things are, machines that are coming off of a clustered production environment. Might even be the way that you do your deployment, I don't know. And then production itself. We want to make our automated testing work in all of those kind of environments. Okay? Kind of like the last topic, test-driven architecture. Who's not familiar with TDI? Okay. Good. I'm going to take you first on a Wayback Machine. This is the computer that I started with. Oh my God. It was 1968. I was a freshman in 9th grade, right, at Baltimore Polytechnic Institute, which is in Baltimore, Maryland, which is where I was born, right? Our school had a policy that that everybody did theory and practice, very Teutonic, right? So you had to get good grades, because I was in the A course, and you had to go out for sports. So I went out for American football, and I forget what they call it. It's like the wide receiver. And the first couple of days, all that would happen is I'd get into the thing, I'd stand up, and I'd go out for a pass. And the guy standing there would just take me and smash me into the ground. And that got old pretty quickly. So I talked to the coach, and he said, well, you could become a cheerleader, because it was an all-boys school. I said, nah, I don't think so. I found they had a math lab. And I had some aptitude for that stuff. I had done differential calculus by that time. So they had all these analog computers, and cool, look at this stuff I can do. They had relays, and I could build adders and stuff. And then they got this guy, right? It was the first computer in the Baltimore City school system, and I learned how to program it, okay? And I learned how to program it really well, because everything was manual, okay? I mean everything. They had a thick, not shown in this picture, is this thick set of, they were blue manuals. They were about this big, right, with circuits in them and all kinds of wonderful things to go work through. I figured out that you could take this machine, if you turned this knob up here, you could put it into single instruction mode, which was manually how you went about debugging your programs, right? Because you didn't have IDEs and that kind of nice stuff. You just watch the values go through and say, whoa, that doesn't look right. Let's go change it. Boom, let's go. It also had a it was like a micro instruction architecture where you could go through each of the micro instructions. The machine had 8K of RAM, random access memory. You know how we talk about core? This machine had real cores, right? These tiny little magnetic donuts, with 3 wires that go through them, one read, one write, and one sense. By reading the manuals, I realized that when you go through a read cycle on this stuff, the hysteresis flips, and the parity is now wrong within the word. So the very next thing it does is goes back and rewrites this stuff so it's correct. So I said, step, step, stop. Turn it back into single instruction mode or run, and press the green key over here that says run. It's amazing how I still remember these things. And immediately the machine would fault and get a parity error, and the big red light would come on. The emergency stop would happen. It was all really fun. Everything was very, very, very manual. You wanted to load a new compiler onto the machine. You take the stuff, you put, you can either take the big long deck, or we were advanced, we had a 5 megabyte disk drive. You could take the compiler and stick it onto the disk drive so you wouldn't have to use the card deck every time. It was all done piece by piece, right? I mean, what amazes me is how long it took to put in we got a punch card, well, we had a punch card reader, but they got another one that could read cards that were like marked. Ooh, high tech. Manual, right? When I look back at now, I happen to run Fusion, VMware stuff. I want to add a new disk drive. It's like, oh, I want a new disk drive. Boop. There, second disk drive. Make it a SCSI interface. Boop. And how big do you want that? 3 gig is fine. Boop. Right. It wasn't like it back then. Everything was done manually, right? Now, the state of the art nowadays is to manage everything on virtual machines. How many people deploy onto virtual machines in here? Woo! You guys are good. You guys are good. So this will speak directly to you, right, if you're not already doing it this way, right? We want to automate deployment and provisioning onto these virtual machines and test that everything went correctly, right? So my favorite tools in that space are Vagrant and Puppet, right? And I love Puppet because it directly supports an RSpec. So I can actually test that things are going on as I go about doing things. I can run the Vagrant script, put together a server, and then test that all the things that went on in there happened correctly. Now, you may go back and think that this is kind of like weird, right? Because why am I testing that files wrote onto the virtual machine? That's not, the Vagrant and Puppet are not part of my system under test. They are the system to do things with. Well, the rationale behind that is we want to make sure that when new pieces of infrastructure get installed, like a new Apache server, or the configuration for our servers, our Apache servers, that they're all in the right place. So that the stuff that Puppet has created creates an environment that we can trust. Are there people in here that are using RSpec with Puppet, perchance? People using Puppet? Okay. Take a look. I mean, it's a really great way to basically do test-driven development on infrastructure. And it feels kind of weird at first. All right. Anyhow, we've come a pretty long way here. All right. We've been all the way down from talking about some process stuff to talking about some of the techniques that we might want to use to let us rest easy at night. We need to be able to have that certainty that when we press the move it to production button, right, for a push button deployment, that everything goes right. We can have a nice sound sleep. However, if you were to ask me back in 1968 what deployments would look like, using virtual machines and Puppet and Vagrant, what is all this stuff all about? Right? I would have had no idea what you were talking about. And it really amazes me how many organizations are out there that are living like they're in 1968. Right? There's very, very, very little reason that we shouldn't do our most complicated and complex stuff with TDI. Right? It's really the wave of the future. Right? It's not about having release notes, scripts, people up on the middle of the weekend, and the middle of the night and the weekend. Right? We want to get down to reducing time and cost so that our single lines of change that we wanted can happen quickly, reliably, and without fear, and without heroics. That's pretty much it. Here's some thoughts. There's always 6 of them. Isn't that amazing? Okay? The things that I want to leave you with is it all starts with the code, right? And you're never going to test your way out of poor quality code, right? And I don't want you to get good at fixing defects. I want you to get good at creating quality code, right? It's always the cheaper thing in the end. Testing gets us closer for lowering costs and raises the quality. right? TDD will help us make quality code. Various flavors of ATDD help us get closer to having quality requirements, the real requirements. Again, I'm going to go into depth with this tomorrow in the cucumber stuff, right? But that's what we really want to get to, is executable requirements. Make sure you give your product owners Amazon Prime. They'll be better and they'll be happier. Getting rid of the friction, okay, within your release cycle. Figure out the ways to lubricate that away. Those darn databases, figure out how to treat them like code. Right? Continuous delivery is more than just a bunch of tools that are going to pour them onto a problem and make things better. It doesn't work that way. They're necessary, but they're not sufficient. Finally, the future belongs to those who evolve. Releasing is the new rate-limiting step. So we've got to learn to inspect, adapt, or die. That's kind of it. So long. Thanks for all the fish. And we have a couple minutes left for some questions, some answers, some debate, and then we depart. Thank you very much.